Hello everyone, my name is Alnur Elbarer and I'm a Field Applications Engineer with the STMicroelectronics IoT and Cloud Apps team. In this video, we'll explore AWS IoT Greengrass Fleet Provisioning, a service designed for users who need to onboard and manage large fleets of IoT devices. Fleet provisioning allows devices to self-register with AWS IoT Core using templates and claim certificates, making it ideal for deploying and managing multiple devices at scale, rather than individually enrolling Greengrass Core devices. If you're interested in the standard Greengrass Core individual enrollment process, check out the video linked below. Today, we'll focus on automating fleet provisioning for large-scale device deployments. The GitHub repository that you see on the screen now can be found at github.com/stm32hotspot/fleet provisioning. It can also be found linked in the video description down below. This repository provides the set of scripts and templates required to automate the AWS IoT fleet provisioning with Greengrass v2 on the STM32MP1 and MP2 devices. This repository will be used and referenced throughout the demonstration, so ensure that you have it downloaded before following along with today's walkthrough. Next, let's go through the key scripts in this repository. First, we have create fleet provisioning stack.sh. This script creates the Cloudformation stack for the IoT resources and Greengrass Core devices. Next, we have update config.sh. This populates our config.json file with the AWS configuration. It collects the necessary data for the IoT setup. Then there's execute.sh, which transfers all the necessary files over to the STM32MPU device and runs setup.sh to configure everything remotely. Setup.sh configures the AWS IoT Greengrass and fleet provisioning, installing dependencies, and sets up the AWS Greengrass Core device. To remove Greengrass, we have an uninstall.sh script. It stops and removes the Greengrass service from the device. And as we've spoke about, config.json holds all the necessary configuration details, like the AWS regions, certificate paths, and IoT endpoints. There's also a template.yaml file, which is the CloudFormation template that provisions the necessary resources. And lastly, we have device cleanup.sh. This cleans up IoT resources by deleting the IoT things, certificates, and the Greengrass Core device. These scripts help automate the setup and cleanup of AWS IoT Greengrass with fleet provisioning. Before we begin the demonstration, let's go over the prerequisites. You'll need either an STM32MP1 or STM32MP2 discovery kit. These boards must have the latest version of the ST Linux starter package image installed. This link describes all the steps required to update to the latest starter package image. Additionally, the board must be accessible over your local network. This link provides all the steps required to set up your Wi-Fi connection. Both links will be listed in the description below. Also, you'll need an AWS subscription with an account configured with the correct permissions to manage IAM, IoT, Greengrass, and CloudFormation stacks. You'll also need AWS CLI installed on your host PC. This installation must be configured with the AWS account described above. Git bash is also required for Windows users, as you'll need a Unix-like shell compatible with the scripts provided in this repository. And lastly, you'll need SSH access to ensure that you can connect remotely to your STM32MP1 or MP2. Off camera, I've already completed all the prerequisites for the demonstration. So now I can continue with the setup steps. I'll open my repository browser side by side with the Git bash terminal. To do so, I'll right-click on the desktop and select Git bash here. This opens a Git bash window with the directory as desktop open. Next, I'll clone the repository and navigate into the repository with the commands provided in step 1. I'll copy the commands and right-click to paste them. Now we can see that I'm in desktop and fleet provisioning. And if I type ls, it lists all the scripts provided in the repository. As you can see in the steps, the first script that will run is the create fleet provisioning stack.sh. I'll copy the command here and paste it into my Git bash window. I'll have to replace the stack name with a unique stack name. Today I'll call it demo stack. And I'll run the script. As we spoke about previously, this script is responsible for creating the Cloudformation stack, which sets up all the AWS resources that will be required for our fleet provisioning process today. This script execution may take some time, so I've sped it up for the purpose of this video. Feel free to pause here while you wait for your script to complete successfully. Next, we'll run our update config.sh script. This script will update our config.json file with the parameters that it parses from template.yaml as well as the thing group name that we provided. To do so, I'll copy this command and then paste it into the Git bash window. I'll have to provide it with a unique thing group name, so I'll call it demo group. Next, I'll just hit enter. Now that we've configured AWS and populated our config.json file, we can run the execute.sh script. This script will copy a config.json file as well as setup.sh over to our STM32MPU. Prior to running the script, I'll just clear the Git bash window. I'll copy the command over from the README and paste it into the Git bash window. Also, I'll need to replace the board IP address with the IP address of our STM32MPU discovery kit. I have mine handy, so I'll paste it as well. Now we can click enter. First, it will copy all the required scripts, and then the config.json file, and then the claim certificates. Next, it will configure and install all the prerequisites on board the STM32MPU. In real time, this step took about 5 to 10 minutes, so be patient while the script runs and please don't interrupt script execution. I've sped it up for the purpose of this video, but please feel free to pause the video while you wait for your script execution to complete. Once you see the line successfully set up Nucleus as a system service, your script execution has completed successfully. As you can see in the Git bash terminal output, a unique thing name has been generated for your device. If we'd like to verify that our device was created successfully in AWS IoT Core, we can scroll down and copy the line from step 5. Paste this into our Git bash window and hit enter. This is an AWS CLI command that lists all the healthy devices that are currently connected as Greengrass Core devices. If we see here, most recently, a device with the same name as the one that was generated during the script is listed as healthy. Also, if we navigate to IoT Core and then all devices and things, we'll see our thing created here. And under Greengrass devices and core devices, we'll see a newly created STM32MPU discovery kit device. There are several steps to clean up after this demonstration. To uninstall all the dependencies that were added to the discovery kit, we'll need to SSH to the board. To do so, we can copy the command here. SSH root at board IP address. Again, you'll have to replace this board IP address. So I'll copy that and paste it. And now you can see that we're SSH'd into our discovery kit. Next, we can copy these commands and run an uninstall script. This script uninstalls all the Greengrass dependencies that were installed on board the discovery kit. Next, we can exit, and we'll want to delete the thing and the Greengrass Core device that we added to our AWS IoT core. To do so, we'll run the device cleanup.sh script. We'll have to add an argument, -t, for thing name, and then we'll want to copy the thing name that we see present in AWS IoT core and hit enter. This script will delete the thing, the certificates, detach policies, and delete the IoT Greengrass Core device as well. And lastly, in AWS, we can search for Cloudformation. If we go to our Cloudformation, we'll see several stacks. Definitely there should be a stack called Demo Stack, the name we used to run. And we'll just hit delete here. This will delete all the resources that were created with our Cloudformation template. After running these 3 steps, we've completely cleaned up after our demonstration. That wraps up the video. All the steps we covered today, along with more detailed information, are available in the GitHub repository. I really encourage you to review the repository, especially if you have any issues, feel free to view the troubleshooting section. The repository is also a living resource that will be maintained, so it's the most up-to-date place to find information and instructions. So be sure to check back regularly for any updates. Thanks for watching, and good luck with your setup.